Okay, so for this first one, you can see I'm going to write the rules on the right that we're going to use for each problem. This is rule 6, I think, the inverse 1. Okay, so the rule says if you can write, if you look over here, the rule says if the base of the log matches the base of the argument, then the answer is just the exponent. So if we can write the argument of this problem as 5 to the something, since the base is 5, then whatever the exponent of this is, that'll be the answer. Okay, so the fact that 25 is 5 squared, I'll rewrite this. Okay, we'll rewrite, so this is log base 5, and then we could rewrite 25 as 5 squared. And then now using this rule, the fact that this base and this base match, that means the answer is just the exponent. The exponent is 2, so the answer is 2. Okay, we're going to use the same rule as the last one, the inverse rule. So if this base of the log matches the base of the argument, then the answer is the exponent of the argument. Okay, this one's a little tricky. So that means we need to write 1 over 81 as 3 to the something. So I think this is one of the trickiest ones to do without practice, or if you haven't had practice with it. Okay, so I'm going to do some little scratch work off to the side to just be able to write 1 over 81 as 3 to the something. And I'm going to do it a little different than the way a lot of people did it in class, just so you can see that there's different ways to do these. Okay, so I'm going to first I'm going to use this idea that, actually here, let me write this. So I'm going to use the idea that if you do, just in general, not for this problem, but in general, if you do 1 over x equals x to the negative 1. Okay, that's kind of almost a definition of a negative exponent. So we're going to use this as a rule, kind of. Okay, so that means 1 over 81 could be written as 81 to the negative 1. Okay, and then 81 is 3 to the 4th, and so we can rewrite 81 as 3 to the 4th, and then that's still to the negative 1. And then we can use the idea that if you have something to an exponent, so this is like 3 to the 4th, so you have something to an exponent, and then the whole thing is raised to another exponent, then you multiply these exponents. And so this becomes 4 times negative 1 is negative 4, so this is 3 to the negative 4. Okay, so we see that 1 over 81 equals 3 to the negative 4. Okay, so if we go back to the problem, we could, here I'll rewrite this, so log 3 of 1 over 81, that equals log base 3. Okay, so we already realized that 1 over 81 is the same thing as 3 to the negative 4. And then if we use this inverse rule, now that for the rule, if the bases match, the answer is the exponent. So these bases match, so that means the answer is the exponent, which is just negative 4. Okay, the big thing, or the first thing to realize, is that when they write ln, here they have ln of e to the negative 2. Just knowing that ln really means log base e. Okay, so I'll rewrite this, ln e to the negative 2. ln really means log base e, so this means log base e of e to the negative 2. Okay, so all we did was change ln to log base e, but that e to the negative 2 stayed the same. Okay, now we can use the inverse rule. the fact that these bases match now. The answer is just the exponent, and that's it. So the answer just is -2. Okay, so for this first problem, we have a log of a fraction. So here we have, here we have log base b of x to the 4th over z squared. Okay, almost always, maybe always, at least almost always, when you have a log of a fraction and you're simplifying, you're going to use the quotient rule. So quotient rule, if we look over here at this rule, if you take the log of a fraction, you're going to split it up into two fractions, and then the top of the fraction goes as the argument of the first log, and then the bottom of the fraction goes in the argument of the second log. Okay, so that's what we're going to do. So we're going to rewrite this. First log, log base b, the numerator of the fraction, x to the 4th, that goes in the first one. And then we'll have another minus another log base b. And then the denominator of the fraction, the z squared, goes in the second log. Okay, and then when you're simplifying these, you never want to have, we have these arguments, x to the 4th and z squared. You never want to have exponents in the arguments for a final answer. So the next step will be using the power rule, and in the power rule, all it is you take whatever the exponent is and you bring it out front, and then it gets multiplied by the whole thing and becomes that. Okay, so all that means is we're going to rewrite this 4 here is going to come out front, and it'll be times log base b of x, and then minus the same thing, the 2 from the z squared. This 2 here is going to come out front, and then times log base b of z. And that's the final answer. Okay, so just like some of these other ones, if you have log of a fraction, we'll use quotient rule first and split it up as 2 logs subtracted. One thing, this is ln, which is really a log. It's log base e. Ln is just another way to write log base e. For this problem, we'll keep it as ln the whole time. We won't rewrite it as log base e, but we could. But for this one, it doesn't matter. Might as well just leave it. Okay, so starts out ln of a fraction, and it's x to the 5th z squared over y cubed. Okay, so if we use the quotient rule, we'll rewrite this as 2 logs subtracted, so ln of something minus ln of something. The rule says that whatever, a is the numerator of the fraction, and then c is the denominator. And so whatever is the numerator, a, is going to go in the first log. So it doesn't have to be, a doesn't have to be just a single thing. It could be 2 things multiplied. So like in this case, the numerator is 2 things multiplied, x to the 5th times z squared, and so that thing will, both those things together, since that's the numerator, that goes in the first log, and the denominator will go in the second log. Okay, so the first log is 2 things multiplied, and so we can change that. So we can use the product rule. So product rule over here says if you have the product of 2 things multiplied, a and c are multiplied, you can split it up into 2 logs these two logs that are added. And then the a, one of the things multiplied will go in the first log, and the other thing that's also multiplied will go in the second log. Okay, and we'll only do that here. We'll do that just to this first one. The minus ln of y cubed will just stay at the end. Okay, so just splitting up this first log here, we can rewrite this as ln x to the fifth plus ln of z squared. And then the minus ln y cubed just stays. Okay, and then since all three of these arguments have exponents, exponent, 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 we can use the power rule and just bring each exponent and multiply it out front. Okay, so this 5 can get written first, and then just times ln x plus, and then the 2 from the z squared, that 2 comes out. I'm just left with ln z minus, and then the 3 from the y cubed can go out front, and you just have ln y. And so that'll be the final answer for that one. Okay, so I don't know if this one's kind of tricky maybe, but we're going to be using a lot of the same rules that we've been using, but backwards. So before in the problems that we've done before, we've used the power rule, but with the power rule so far, we started off with the left-hand side and changed it to the right-hand side. So we usually start off, if the argument has an exponent, we bring the exponent and multiply it out front. But we could go the other way around. If something's multiplied out front, like if you have something that's multiplied by a log, you could bring it in and make it the exponent of the argument. And if you took this in and made it the exponent of a, it becomes this. And so that's what we'll do for each of these. Okay, so 3x plus 2 ln y minus 4 ln z. One thing, these are all ln's. They all have the same base, and so we can only use this power, oh, never mind. Next rules we can only use when they have the same base. This we're kind of doing each one separately. Okay, so first one, we'll take this this 3 and bring it in and make it the exponent of x. At the same time, same step, we'll take this 2, bring it in and make it the exponent of y, and then we'll take this 4 and bring it in and make it the exponent of z. So this will become ln x cubed plus ln of y squared minus ln of z to the 4th. Alright, so all those things that were multiplied out front just became exponents. Okay, and I think actually, just so we can be clear, the directions were condensed into one log, I think it said. And so yes, that's what we're doing. You see we have 3 logs. Our final answer is going to be written in one log. Okay. Okay, next step, we'll basically focus on these two first. Okay, same thing, we're going to be using a rule kind of backwards. So now we have kind of this right-hand side, 2 logs added that have the same base. And so we'll end up each of these things here, the arguments of each of these, we'll just combine it into one log and multiply those 2 things together. Okay, so this becomes, this whole thing here becomes ln of x cubed y squared. Okay, and then just minus ln z to the 4th. That just kind of stays the same on the outside. Okay, and then the last thing, we'll use quotient rule. So we have a log of 2 things subtracted, so we kind of have this right hand side here. And so that means we can take each of these arguments here and make that the numerator of a fraction once we combine these into one log, and then take the argument of the second thing and make it the denominator of the fraction. Okay, so at this point we'll write all as one log ln, the fraction. Okay, so this first thing becomes the numerator, and this second thing here goes down into the denominator. And that's the final answer. Okay, I was gonna not do this one and see how many people got this problem. This might be kind of the trickiest, at least the first step, or especially the first step is kind of tricky. So if we want to make this all into one log and get rid of that addition, basically add these two things, the only way you can really add two logs or add a log in something is if it's two logs with the same base. So that 1 obviously isn't even written as a log, so it, the question is can we write 1 as some log that has the same base as this other log? This other log has base 4, so can you rewrite 1 as a log with a base 4? And so we can. So like 1, the first word we'll use it kind of backwards. So we start off with the right hand side. We start off with 1, and then we can make it log base b of b. We can make it log base 5 of 5 or log base 10 of 10. So for us, it makes most sense to make this log base 4 of 4. So that 1 just becomes log base 4 of 4. And then we can rewrite this. Okay, before we add these, we can't add these if either of them has a something multiplied out front, then we can't use the product rule where we can combine these into one log. So this 3, we have to get rid of that somehow. And so next thing we can use the power rule. Same thing, we're going to kind of be using it backwards. So if you have something multiplied by a log, in this case you have n is multiplied by this log, then you can take this n and bring it out, or bring it inside, and make it the exponent of the argument. Okay, so this first thing will stay the same, log base 4 of 4. And then this 3 we'll take and bring inside and make it the exponent of x. This just becomes log base 4 of x cubed. Okay, so now that we have two logs that have the same base and nothing's multiplied out front, we can use this rule here. Okay, and all we're going to do is take their arguments, take whatever this argument is and whatever that argument is, and then combine this into one log with these two arguments multiplied. Okay, so this becomes all one log, same base 4, and then these two arguments here just get multiplied inside. So 4 times x cubed. And that's it. So now we started off with two things added, and we ended up with just one log. And that's what we wanted. Okay, so kind of similar to the last one. We want to combine this all into one log. We have two logs subtracted, so we have an idea we're going to combine them into one log using the quotient rule, and we'll kind of combine these. Since it's subtraction, we'll combine it into a log of a fraction. But we can't use quotient and product rule. if there's something multiplied by the logs out front. So here we have a half, and then here we have a 2. And so, yeah, we can't use quotient rule until we get rid of that. And the way to get rid of it is to use power rule. So if you have power rule, I'll kind of keep explaining this. So power rule will start off with the right hand side. If you have something, in this case n, that's multiplied by a log, then you can take this n and bring it in and make it the exponent of the argument. If you do that, it becomes this. So that's what that rule says. Okay, so here we write this: 1/2 log base 5 of 7 minus 2 times log base 5 of x. Okay, first thing is we'll take this half, bring it in, and make it the exponent of 7. And the same step, we'll take this 2, bring it in, and make it the exponent of x. So that half will go away at the front, log base 5, 7, and then we'll come in as the exponent of 7. This log base 5 of x, and then the 2 comes in as the exponent of x. Okay, so now that we have two logs with the same base, nothing's multiplied by either log, and so when that's the case, we can take the first thing, make it the numerator fraction of a log, and take the second thing and make it the denominator. Okay, so this is going to be log base 5 of some fraction. Okay, the top of the fraction will be this first thing, and the bottom of the fraction will be this second thing. Okay, and that's the final answer. So now we started off with 2 logs subtracted, and we combined it all into 1 log, and that's what we wanted to do. Okay, so kind of 2 things. The main rule that we're going to use is the inverse rule, where we'll try to make this argument of the log have the same base. We'll rewrite it as something to the something, where these bases match. They end up having the same base. So that's the rule that we're using. We also have to use the idea, though. The original problem, there's no base written, and so we just have to know if there's no base written, it's implied that there's really a base 10. So it's always 10 if there's no base written. Okay, so really this is log base 10 of 1,000. Okay, and then in order to use this rule over to the right, we have to make this argument be 10 to the something. Since the base is 10, we need to write this as 10 to the something. Okay, so 1,000 is 10 cubed. Okay, and then now that these bases match, these things match, so that means that the answer, using the inverse rule, the answer is just whatever that exponent is. Okay, so this one is similar to it's actually almost the exact same thing. I forget which number. It was log base 3 of 1 over 81. Yeah, this one's almost the same thing. So we're gonna do this another way, just to be different, I guess. So we're gonna do it the same way. What am I talking about? Yeah, let's do it the same way as the last one. I think it's easier. Okay, so we're gonna say we're gonna do some little scratch work off to the side. We'll see that 1/9 is the same as 9 to the negative 1. Yeah, so 1 over x, in general, 1 over x is the same as x to the negative 1. So 1 over 9 is the same as 9 to the negative 1. Okay. So 9 to the negative 1 is the same thing as 3 squared to the negative 1, since 9 is 3 squared. And then we can use just the rule of exponents, that if you have something to an exponent and the whole thing's raised to another exponent, then you multiply these two exponents. And so this 2 times negative 1 is negative 2, so this is 3 to the negative 2. Okay, so we realize 1/9 is the same as 3 to the negative 2. Okay, so that means that this log base 3 of 1/9 is the same as log base 3 of 3 to the negative 2. Okay, and then now since these bases match, then using this inverse rule, then the answer is just the exponent. So the answer is just negative 2.